Hello everyone, today we'll be going through all of the challenge questions in Edexcel's Applied Year 1 textbook from chapters 6 to 7, and this is the third video in the series for Year 1 statistics. Okay, our first question from exercise 6a. The independent random variables x and y have probability distributions. The probability that x is equal to an eighth for x is equal to 1 to 8. And the probability that y is equal to 1 over y for y equals 2, 3 and 6. And now we're asked to find the probability that x is greater than y. So we can draw two tables showing the probability distributions for x and y. So our first one for x will look like this, x on the top and the probability that x is equal to x on the bottom. So we have 1, we have 2 and so on and so on and so on, until we get 7 and 8 at the end, and we know they will all equal 1/8. And you'll see that that will add to 1. And doing the same for y, we have y on top and the probability that y is equal to y on the bottom. And here we have just 3 values of y, 2, 3 and 6, and they'll give us 1 over y. So for y equals 2, that's 1 over 2. For y equals 3, that's 1 over 3, and for y equals 6, that's 1 over 6. And the half plus a third plus a sixth is also equal to 1. Okay, and we've been asked to find the probability that x is greater than y. And for this, we can consider the separate values of y. So for y equals 2, that means that x must be greater than 2. And for y equals 3, we know that x must be greater than 3. And for y equals 6, that means x must be greater than 6. Okay, so first of all, the probability of x being greater than 2 is the probability that x equals 3, 4, 5, 6, 7 or 8. So that's 6 out of the 8 possible values of x. And for x is greater than 3, there will be 5 values of x. And for x is greater than 6, that's just 7 and 8, so that's 2/8. And so, the probability that x is greater than y is the probability that y equals 2 and x is greater than 2. So that is 1 over 2 times 6 over 8, plus the probability that y equals 3 and x is greater than 3. So that is 1 over 3 times 5 over 8. And finally, plus 1 over 6 times 2 over 8. And that is equal to 5/8. And that is our final answer. Okay, and next question is from mixed exercise 6. A driving theory test has 50 questions. Each question has 4 answers, of which only 1 is correct. Annabelle is certain she got 32 answers correct, but she guessed the remaining answers. She needs 43 correct answers to pass the test. Find the probability that Annabelle passed the test. So we know that the probability of getting the questions right is a quarter from here. And we also know that she needs 43 minus 32, so that's 11 correct answers to pass. She knows that she got 32 answers correct, and there are 50 questions on the test, so that means she guessed the other 18. Each guess has a 1 in 4 chance of being correct, and we can model this using a binomial distribution. So we have that x is binomially distributed with the number of trials, 18, and the probability of it being correct, 1 in 4. And now we're trying to find the probability that x is greater than or equal to 11, because we need 11 correct answers. And using your calculator, you can do 1 minus the probability that x is less than 11, and that is equal to 0.0012 to 4 decimal places. Okay, and our final question is from exercise 7b. A test statistic has binomial distribution b, where n equals 50 and the probability of success equals p. Given that the null hypothesis is p equals 0.7 and the alternative hypothesis is p is not equal to 0.7, part A says find the critical region for the test statistic such that the probability in each tail is as close as possible to 5%. So first of all, to do any calculations, we need to assume that h0 is true. So we get that x is binomially distributed with n equals 50 and p equals 0.7. So looking at the lower end of the tail first, we need to find a value c such that the probability x is less than or equal to c is as close as possible to 0.05. And using your calculator, you can see that the probability x is less than or equal to 29 is equal to 0.0478, and the probability that x is less than or equal to 30 is equal to 0.0848. And you can obviously see here that this will give us the closest value to 0.05. So our critical region starts with x is less than or equal to 29. Okay, and in our other tail, we're looking for a value of d such that the probability that x is greater than d is approximately equal to 0.05. So the probability that x is less than or equal to d is approximately 0.95. And using our calculator to find these values again, we have the probability that x is less than or equal to 40 is equal to 0.9598. And the probability that x is less than or equal to 39 is equal to 0.9211. And this value up here is the closest. So the other end of the critical region is x is greater than 40. Remembering that we had a strictly greater than sign up here. So our critical region is x is less than or equal to 29 and x is greater than or equal to 41. Okay, Chloe takes two observations of the test statistic and finds that they both fall inside the critical region. Chloe decides to reject H0. Part B says find the probability that Chloe has incorrectly rejected H0. So this is the actual significance level of our test. And to find this, we need to have the probability that x is less than or equal to 29, which we have as 0.0478. And we also need the probability that x is greater than or equal to 41. But at the moment, we only have the probability that x is less than or equal to 40. So to find the probability that x is greater than or equal to 41, we have to take away the probability that x is less than or equal to 40 from 1. And so we get 0.0402. So now we can find the actual significance level of the test, which will give us the probability that Chloe has incorrectly rejected H0, and that will be equal to 0.0478 plus 0.0402, and that is equal to 0.088. And therefore, as Chloe takes two observations and they both fall inside the critical region, the probability that Chloe incorrectly rejects H0 is equal to 0.088 squared, which is equal to 0.0077 to 4 decimal places. And that is our final answer. And that is the end of part 3 for Edexcel's Applied Year 1 Statistics. I hope you enjoyed this video and I'll see you for part 4.